For 35 years, the Hubble Space Telescope has given us the most spectacular, brilliantly illuminated images of the cosmos. But one of its most profound recent discoveries is what happens when a massive cosmic structure goes entirely dark. In January 2026, astronomers pointed Hubble toward a highly unusual patch of space just outside the spiral galaxy Messier 94, located about 14 million light-years away. They were looking there because ground-based radio telescopes had picked up something strange, a colossal 4,900 light-year-wide cloud of hydrogen gas. This cloud holds about 1 million times the mass of our Sun. To hold that much gas together out in deep space, the structure has to be anchored by an immense amount of gravity. The math dictates this hydrogen is wrapped inside a dark matter halo weighing 5 billion times the mass of our Sun. With that kind of extreme gravitational pull, this structure should have easily compressed all that gas, sparked massive star formation, and created a highly visible dwarf galaxy. But when astronomers used Hubble's highly sensitive advanced camera for surveys to look for those stars, they found absolutely nothing. There is not a single star inside this massive structure. This absolute absence of light provided the first physical proof of an object physicists had only theorized about, a failed galaxy. Now officially named Cloud 9, it is a massive cosmic structure built entirely of gas and dark matter. Under the standard model of galaxy formation, dark matter acts as an invisible gravitational skeleton. It pulls in free-floating cosmic gas until that gas pulls together, compresses under the pressure, and ignites into stars. But during the epoch of reionization, intense radiation from the first stars flooded the early universe, heating free-floating hydrogen gas to 10,000 degrees. Because this heated gas became so highly energetic, smaller dark matter halos lacked the gravitational strength to pull it all together. The gas was simply too hot and erratic to compress. Structures caught in this trap are officially classified as RELHICs, or reionization-limited HI clouds. They are galactic foundations that captured some gas but were permanently prevented from forming stars. Cloud 9 is a pristine, frozen relic from the universe's first billion years, a structure that never reached the pressure required to spark its first star. Cloud 9 is not an isolated case. Just weeks after it was confirmed in early 2026, researchers announced the discovery of another dark target named CDG2. CDG2 is hidden roughly 245 million light-years away in the Perseus cluster and is overwhelmingly heavy, estimated at 99.98% dark matter. Unlike Cloud 9, CDG2 actually managed to form exactly 4 lonely globular star clusters before its star formation process permanently shut down. Together, these twin discoveries provide physical proof for long-standing theoretical models. They show our universe is heavily littered with invisible, abandoned cosmic houses. Finding these starless halos solves a major headache in dark matter research, known as the cusp core problem. In a normal galaxy, violent stellar activity, like exploding supernovae, creates massive shockwaves. These explosions physically heat up the dark matter and push it out of its natural, densely packed position at the center. This stellar contamination means astrophysicists can't map the true, undisturbed structure of typical dark matter halos. The stars keep moving the scaffolding. Cloud 9 is the ultimate laboratory. With no stars, its dark matter hasn't been blasted away, remaining in a perfect state of hydrostatic equilibrium. Paradoxically, a galaxy completely devoid of stars provides the only pristine environment where astronomers can clearly measure the invisible scaffolding that holds the universe together. But there is a catch. To weigh these invisible halos, astronomers have to analyze the hydrogen gas trapped inside them. Historically, the math used for this assumes the cloud is sitting in a perfectly empty vacuum. This image maps the projected gas density of the cosmic web. Recent research by astronomers Francesco Turini and Alejandro Benitez Lambe shows objects like Cloud 9 don't exist in a vacuum. Instead, they are actively compressed by the intense environmental pressure of nearby cosmic structures. This chart plots the error in recovered halo mass against concentration, revealing a specific bias caused by this external pressure. The squeezing forces the gas inward, tricking astronomers into overestimating the total dark matter mass, while simultaneously underestimating how concentrated it is at the core. The research serves as a stark warning to astrophysicists. If they fail to account for local cosmic environmental pressure, the mass measurements of all future starless galaxy discoveries will be deeply flawed. By mapping Cloud 9, Hubble exposed a critical error in how we weigh the hidden universe. The discovery forces us to update the models used to measure the cosmos. Today, the Hubble Space Telescope is operating in its 35th year. It is currently relying on a single, final functioning gyroscope just to maintain its stability against the void of space. Yet despite its mechanical fragility, it continues to supply the evidence for new cosmological models by confirming the absolute absence of starlight in a region where we expected a galaxy. Pause for effect. Hubble's legacy is often measured by the brilliant light it has captured. But the events that failed to happen in the universe, the stars that never ignited, are just as critical to our understanding of the cosmos.